All right, hi, my name is Todd Duss, and I work here at Synaptics, focusing on our AI microcontroller line. And today we are introducing our SR series of products. So this is the SR100. And the SR100 is based on a Cortex-M55 microcontroller plus a U55 neural processing device. So what we focus on this part is vision and audio AI. So our primary use cases are anything that has a vision input or audio input and you want to run some sort of inferencing on it. That's where this part will shine.
Is it on there?
Yeah, so it's on here. So it's actually the black one there, and then it's got another one is the silver one up there. So the silver one acts as a debugger. So we're using our own part to do debugging of the device on that kit. So I'll just kind of go through some of the slides. So this, this device, as I said, has the Cortex-M55, the U55, and then we also have a power domain with the Cortex-M4 and our own Synaptics neural processing unit as well. And what is unique about our product, I'll show on this next slide, is we have what we call gears. So we have different gearing for whether or not you need high power processing or if you want low power. So the way that this works is I'll use an example of, let's just say, a video doorbell. So in a video doorbell, especially if it's battery powered, you don't want it on all the time because it will consume too much battery. So you need to have it off and then wake up on an event. So in our low power domain here, what we can do is we can sample camera images at certain frame rates. So for example, 1 frame per second, 3 frames per second, etc. And we can, number one, we can store them in a buffer. So later you can go and look to see what had happened before the event. And then number two, in there we have what's called a change detection circuitry. So we look at the first frame you capture and then the second frame. We compare the pixels to see is there any difference. And if there is a difference, then we can wake up to this next gear. So we wake up to the next gear, and in here you can do a simple inference to say, is there actually something there that's interesting? So you could have an object detection here, and if it sees that there's something interesting, you wake up to the next higher gear, and in this gear you could detect whether or not it's you personally. So we have face detection algorithms to say whether it's person A or person B. So that algorithm could run and then decide what to do. So you could capture a picture, you could alert someone that Bob is here or whatever. So that's what's going on in this. So this is our different gears, and you can go through them automatically in code.
So here you define as the ARM Cortex-M55 and the U55, Cortex-M4, your proprietary MPU.
Yeah.
What is the architecture of the lowest gear?
So there's no processing, there's no microcontroller in here. It's all hardware logic that we've built with different state machines. So they're programmable state machines to determine when you want the camera to be on. We also support audio use cases, so you can have different microphones come in and you can listen to the audio, and if there's a voice activity, wake the system up. So it's all hardware logic that we have designed that runs
on the SoC.
On the SoC, yes.
So it's like a ASIC kind of portion or something like that?
Yes, exactly.
And that can be customized for different scenario?
Yeah, so it's set on the SoC and it's programmable. So you can then choose frame rate, how responsiveness that you want, different parameters there. So that's all in that domain.
And it has access to all the senses.
So we have 3 different image sensor capabilities. So we can do MIPI CSI input, parallel camera input, or SPI camera input. It has access to all 3 of those. And then we have 4 PDM microphones as well that we can control.
So you do the vision and the sound.
Yep.
And potentially other things or no?
So yeah, so this hardware is specifically vision and sound, but in our architecture, we have SPI, UR, I2C, other GPIO. So if you wanted to connect another sensor, you could connect that sensor and then run, whatever algorithms you wanted to off of that sensor.
So is M55, a U55 really a great architecture to implement?
Yeah, so the M55 and U55 allow you to do very complex AI thing. So as I mentioned, we have some demos today where you can detect a face, so a particular face, whether it's my face or someone else's face. We have done a barcode scanner. We have people counting. We have a segmentation demo running. So there's a lot of different AI use cases you can run on those processes.
What's the limit?
It's mostly model size. So we have a certain amount of RAM and flash available. So it's just how big your models are, how big the data is coming into the device.
Are there going to be billions of devices with this?
I hope so.
Do you see envision a future that you are helping to design here that's different than what would happen if you didn't have a role to play?
Yes, yeah. So I think we're working on creating even newer products beyond this in the roadmap to help create a world where you have perceptive AI in wearable devices. Battery-powered perceptive AI is the goal.
I also think some people think they hear AI too much, but if it's done in the right way, it's really cool.
Yes.
Then it really people like, oh my God, this makes sense, right? And you want to get to that kind of product.
Yes, yeah. Yeah, and I think this is what AI does, is it helps make decisions based on, environmental input. So, based on a camera, some of the use cases we've talked about is like an elder care. So you could have one of these units in someone's home, and if they fall down, it could detect, oh, hey, this person has fallen down. We need to alert someone that this person is hurt potentially.
I'm thinking maybe the industry, maybe they already do it. They need to color the camera in a certain color so people understand. It's kind of like a privacy camera or something where, don't worry, it's not connected to the cloud.
Exactly, yeah.
It's just doing smart functions. Don't worry about it, but it's pink or red dot or I don't know what, that makes sense for people.
Yeah, I think that's...
Don't worry about it.
Yeah, that's something the industry needs to figure out, is how to communicate that to consumers, because we have examples where the image never leaves the device. So you grab the image, run some sort of inferencing, and then after that the image is gone. So no one ever sees who is there or what it is. It's just all on device.
And this demo is doing something?
Yeah, so I can show this demo. So what this is doing is the part starts up and goes into our low power. Go back to the other slide. Our low power case here. So it's in this always on domain, and it's grabbing 3 frames per second and storing in a buffer, and then it wakes up on a timer. I could do it on a hardware changed event, but there's too many people around, so it wouldn't work very well. But on a timer, and then it will run an AI algorithm to see if there's a human present. And if there's a human present, it captures a high resolution image and then sends it over USB to the connected device, which in this case happens to be my laptop. So I'll get that running. So what I have here is a current oscilloscope, and so I'm going to turn it on, and you'll see the big spike there in the beginning is when the device starts, and then these little guys here are capturing that 3 frames per second. And as you can see, when it goes back, so you'll see when it's only these, is the average current is around 2.6 milliamps, capturing those different images.
Nice.
And so then here what's happened is it's detected that there's a person, and it's captured images and it's sent them over USB. And then we can go in here and see what that looks like. Oops. If I come here, so it stores them on my computer. And then, I can't right click. So it detected my side profile there as a person, and then all the rest that are coming here are the pre-roll images. So it captured all these images at 3 frames per second before that happened.
You don't even need to have a full person.
Yeah, exactly.
You can have a part of a person.
And then it takes a high resolution image there.
Nice. Are there many interesting discussions you have here, the embedded world? People want to do some cool projects with this?
Yeah, so we've had some customers interested in using it for, object detection for different devices to see, is there something around that's interesting to them. There's a lot of security camera sensors. People are interested in using it. There's different applications there.